3, I started off by drawing out my my trapezoid flood plane and channel cross section. I listed the dimensions in my picture below. And for B, it says to compute the flow rate and for a depth of 6 meters. And what I did was I first solved the trapezoid area, and then I solved the trapezoid perimeter, and then I solved for the radius by dividing the area by perimeter. And then what I did was I solved an equation to get a Q, and then with that I calculated Q total, and I got 130.3 meters cubed per second. For number 4, the question asked to find the minimum specific energy for the channel, and what I did was I solved for by using YC plus V squared over 2G, and once I found that number, I solved to get the min specific energy by doing 25, the given number, times 5 plus 4y plus 2yc squared times gravity to get 1.16. And then I also use volume over QA in the middle of that equation as well. And it also asks to explain whether the depth at 1 meter was subcritical or supercritical. I solved a similar equation. I used 25 squared over 5m plus 4 times 116 over 5 times 116 times 2 times 116 times gravity to get 1.003. And being that it's over 1 meter like it asked, it is therefore the depth would be supercritical instead of subcritical because it's over the desired amount, it's greater than. And then to calculate the alternative depth for 1 meter, I then used EY equals Y1 plus V squared over 2G. Then next, for number 5, the question asks to find the critical depth and normal depth of the channel, as well as the surface classification and gauging station. And sort of like number 1, it's sort of the same process to start. I solve for the area and the perimeter of the rectangle, and then solve for the radius by dividing the area over perimeter. And after I got that, I got YA and YC, the normal and critical depths. And after that, I solved by solving for Q again. It was Q equals 1 over n times AR to the square of 2 over 3 times S square of 1 over 2. And then after I got that, I used the direct step method, and then I compared my two values together for number 5. That was for C and D. And then lastly, for number 6, the question asks what are different types of channel cross sections. In my opinion, which type cross section is stable and why? The channel cross sections are semicircles, trapezoids, triangles, rectangles, and squares. And then I listed my opinion about the most stable cross section below in question 6.